Hello everyone. So today we'll be continuing our lecture, which has been started earlier. We have already discussed about the Carnot refrigeration system. So today we'll be discussing how to calculate the enthalpies and entropy at various points. So we'll be calculating enthalpy and entropy at various points. So we need to calculate this one. So for calculating enthalpy and entropy, let us take the TS diagram. So basically, in any refrigeration system, we'll be using the TS diagram, and for that reason, we're taking the TS diagram here. So let temperature is taken in the y-axis, and entropy is taken in the x-axis. So, sorry, for refrigeration system, so there will be two-phase region will be available. Then what we need to do? So for two-phase region, there will be a vapor dome. So two-phase region means there will be liquid and there will be also vapor. So in this phase, there will be liquid, and in this phase, in this area, that will be vapor will be present. And in the middle section or inside the vapor dome, your liquid plus vapor region will be there. Okay. So let us take a process which is occurring from 1 to 2, then 2 to 3, again 3 to 4. So let this is 1 and this is 0.2 and this is 0.3 and this is 0.4. So we need to calculate what is the enthalpy is gained from that point 1 to 0.2. So we need to calculate that one. Sorry. So this is a basically constant pressure process which is used in your vapor refrigeration system or Rankine cycle, that is a reverse Rankine cycle. So we are doing a case study of that only. So we need to calculate the enthalpy gain from 1 to 2 as well as from 2 to 3 and again 3 to 4. So for calculating the enthalpy, what is the enthalpy gain? So if I need to calculate enthalpy gain from 1 to 2, so I can write H1, sorry, I can write H2 minus H1. So what is the formula for enthalpy gain? So this is a constant pressure process. So and your here temperature changed. So at point 1 your temperature is T1 and at point 2 your temperature is T2. But during this process what happens? Your pressure remains constant. So this is a constant pressure process, but the temperature varies. Sorry, but in the 2 to 3 process we can say that here pressure remains constant as well as your temperature remains constant. Means from this diagram we can see that inside the vapor dome your temperature and pressure remains constant. Okay, so for it is quite similar to pressure constant process. So we can say your for a particular temperature and pressure we can get a constant line inside the vapor dome. Okay, so is it now clear to all of you? So next we know from 1 to 2 process means we are adding some amount of heat here. So 1 to 2 process is a heat addition process, we can say. Again 2 to 3, total this 1 to 4 process is a heat addition process. But here 1 to 2 some different amount of heat is being added. Another again 2 to 3 is some different amount of heat is being added, or different types of heat is added, we can say. Again another 3 to 4 different types of heat added, we can say. So which type is being added here and which type is being added here and which type is being added here, that we should know before calculating enthalpy as well as entropy. So we can know here from process 1 to 2 is that during the heat addition process, what happens here? Your temperature what changes. So during 1 to 2 heat addition process, your temperature remains it doesn't remain constant, it changes. And it happens with 3 to 4 process also. But during 2 to 3 process, we can see that your if will be adding heat, then also there is no change in temperature. Okay, so whatever amount of heat is being added during 1 to 2 process and 3 to 4 process, we can tell this is as my what? Sensible heat. What is that? Sensible heat. Or we can tell this as your specific heat. Okay, so that is called as your sensible heat or specific heat. But whatever heat is being added during 2 to 3 process, we call that as your what, that is your latent heat. Okay, so the heat is being added inside the vapor dome, that is known as your latent heat. And here from 1 to 2 process, heat is being added to increase the temperature of liquid, and during the process 3 to 4, heat is being added to increase the temperature of what, steam. Okay, so now I can say this region is saturated liquid region, this region is your saturated vapor region, and inside that there will be presence of your liquid as vapor. So during 2 to 3 process, what happens, your saturated liquid will be converted into saturated vapor. That means total amount of liquid will be converted into vapor. That means there will be a phase change occurring inside that vapor dome. Means entire liquid will be converted into vapor. So is it clear? So we need to do what? We need to calculate the enthalpy change. Okay. So let me insert another page here. Okay. So we had that figure. So I'm drawing that again. So that is here we have taken T, and here we have taken entropy, and this was the vapor dome, and this curve was somewhat like this. So this is a continuous process. So this is 0.1, and this is 0.2, and this is 0.3, and this is 0.4. Sorry. So we need to calculate the enthalpy change during this process, and enthalpy change during this process, and as well as enthalpy change during this process. So if we need to calculate H2 minus H1, then so it is directly the specific heat which is being added here. So for calculating the specific heat, what is that formula? That is Cp dt. Okay, so what is that? Cp here. So Cp is the what? Cp is the specific heat of the liquid. Okay, so Cp and dt, the temperature change. So we can write Cp into T2 minus T1 here. Okay, so this is the formula for finding the enthalpy change or heat added during the 1 to 2 process, that is the sensible heat. Okay, next from we need to calculate the enthalpy change from 2 to 3, means how much heat is being added during 2 to 3 process. So for that we can calculate the H3 minus H2, that will be equal to what? So that will be equal to what? So that will be Hg minus Hf. Okay, then what is that Hg and what is that Hf? So Hg is the amount of enthalpy content within that liquid at the saturated liquid region, and it is the Hf what? Sorry, I did a mistake. So Hg, what? Amount of enthalpy inside that vapor. Okay, and Hf is the amount of enthalpy or amount of heat content inside the liquid. Okay, so at the saturated liquid phase, what is the enthalpy content inside that refrigerant, we can say? So that is denoted by Hf and Hg. So at the saturated vapor region. So from the steam table we can find out these values, as well as in the refrigeration table we can find out these values. So at this point, what is the value of enthalpy, and at this point what is the value of enthalpy? So what is the value of enthalpy at this point? That is known as your Hg, and what is the value of enthalpy at this point? That is known as your Hf. So by calculating these two, we can calculate the value of heat added during this phase change. Okay. So next we need to calculate the enthalpy change during this process. Again, here also what happens, the latent heat is being, sensible heat is being added during this process, so 3 to 4 process. So we can say again H4 minus H3, that will be equal to Cp into T4 minus T3. So if we know the value of temperature and temperature at these 2 points, then we can calculate the value of enthalpy gained here. Okay, so now we can find out the total heat added here. So if we need to find out the total heat added, so Q will be equal to what? That will be H2 minus H1. Okay, so total heat added will be equal to what? H4 minus H1, which will be equal to what? H2 minus H1 plus H3 minus H2 plus H4 minus H3. Okay, So if we know the values of H4 is minus H1, so here H2 and H2 can be cancelled, H3 and H3 can be cancelled. So finally we'll be getting H4. So here we'll be getting what? H4 minus H1. So if we know the value of H4 and H1, directly we can get the value of total amount of heat added during that process. Okay. So next we need to calculate the entropy change. So again, let me draw this diagram. So that is TS diagram, and this is the vapor dome, and this is the process 1 to 2, and this is 1, this is 2, let this is be 3, and this is the 4. Then we need to calculate what? This is the entropy change. So S2 minus S1 we need to calculate. So during the constant pressure process, what is the entropy change? That will be what? Cp ln T max minus T min. Okay, means that is your T final minus T initial, we can say. So what is the T final? Means process is occurring from 1 to 2. So we can write Cp ln T2 by T1. So this is the amount of enthalpy change. Okay. So likewise also we can find out this is the entropy change. Okay. So likewise we can calculate the entropy for the 3 to 4 process. So we can write the entropy change from 3 to 4 process, that is S4 minus S3 will be equal to what? Ln Cp ln T4 minus T4 divided by T3. So this, I think this will be the clear concept to all of you. Next we need to calculate the entropy change during this region. Okay. So again, likewise previously what we have calculated for the enthalpy, what we have done, the enthalpy at point 3 minus enthalpy at point 2. Likewise here also we can calculate S3 minus S2 will equal to Sg minus Sf. Okay. So if the entropy and enthalpy are known at these 2 points, then what amount of heat is required to go from this to this, and that can be calculated. But if we have a point here, okay, so let me show this point. Suppose this is the point, and we need to calculate it to reach up to this. Okay, so we need to calculate it how much amount of heat is required to reach from this saturated liquid region to this point. Okay, so that how can we calculate it? So to calculate this, what we can do, so there is another term here. So there is a term that is dryness fraction. Okay, so what do you mean by dryness fraction? At this point, what is the amount of vapor content? So if we can calculate it, the amount of vapor content at this point, let this point is A. So this point is A. So at point A, what is the amount of vapor content? If that can be calculated, then we can calculate how much amount of heat is required to reach at that point. So what is the dryness fraction? So basically dryness fraction is denoted by X. Okay. So let we can say XA. Okay. So this is denoted by X, and X will be equal to what? M of vapor, that is denoted by mv, divided by m of liquid plus m of vapor. Okay. So if I know what is the amount of vapor is at that point, and what is the amount of liquid is at that point, then I can calculate the value of what? That is dryness fraction. So can you tell me what is the dryness fraction at this point, and what is the dryness fraction at this point? So if our point is this one, then here there will be no vapor. We can say at point 2 there will be no vapor. So if this is no vapor, then it becomes 0. Then your dryness fraction will be 0 at point 2. Okay. Likewise, if I want to calculate the dryness fraction at point 3, then we can say the amount of vapor is maximum here, and there will be no liquid. Okay. So this term will be equal to 0, and let me erase this one. So there will be some amount of vapor, and there will be no liquid. So this will be equal to mv by mv, and this will be equal to 1. So at the saturated liquid region there will be dryness fraction 0, and at the saturated vapor region your dryness fraction will be 1. Okay. So in between saturated liquid region and saturated vapor region, your dryness fraction will be in between 0 to 1. So 0, x and 1. So this will be dryness fraction. So next, if, let me draw this diagram again. So it is somewhat like this. Okay, so let us point 1, 2, 3, and this is 4, and we need to calculate the heat required to reach at this point. Let it be A. Okay, so I can calculate. I need to calculate what? HA minus H2. Okay. So we need to calculate the heat required to reach from point 2 to point A. So that will be equal to what? That will be, let XA is the what? Dryness fraction at point A, and heat required to reach from 2 to 4, that is, HFG. So we can tell this is as our latent heat. So latent heat is what? The amount of heat required to change the phase, that is known as your latent heat. So we can tell this is your HFG, that is your latent heat. Means amount of HFG is required to reach from point 2 to point 4, and the XA amount to XA is the dryness fraction at point A. So HA minus H2, that will be equal to what? That is XA into HFG. Okay, so let XA is equal to 0.5, then so that will be multiplied here with HFG, and that's why your HA minus H2 can be calculated. Okay, so thank you. Next class will be continuing this, and thank you.